Armstrong here with EOS Astrius, here to walk you through the reverse fishbone diagram. The traditional fishbone diagram, or the traditional Ishikawa diagram, and you can see that the effect is on the right, which represents the head of the fish, and the causes, the potential causes, are on the left, all segregated through 6 different categories: man, measure, machine, material, Mother Nature, and method. This with the traditional fishbone, the 6 M's are also broken down into subcategories, and those subcategories are where we call out or explicitly call out the details of the potential causes. Before we move further into our discussion on the reverse fishbone, we need to talk about risk. And we think of risk as bad things only. We think of risk as being negative risk, negative impact, but risk can also be positive. They can be positively impactful to us, positively impactful to our projects. They're also called opportunities. And what do we do with opportunities? We exploit them, we take advantage of them, we enhance them, and so forth. And before we continue on with our changes or our projects, we ask ourselves, what are the potential effects or impacts of a change? What are the potential effects or impact of a Kaizen event? What are the potential effects or risk of your project? What project risk should be identified? And in doing so, why reinvent the wheel? Why not continue using the 6 M's the same way we've always used them? It's one of the 7 basic tools of quality. We just got to flip it around a little bit on the fishbone and use it in the reverse way, and we'll go through that here in a second. Now we just use the 6 M's and reverse the Ishikawa, reverse the fishbone, and that assists to identify potential impacts, effects, and risk of a change or project integration. We can refer to it as a change and effect diagram, a project and impact diagram, solution and impact diagram, project and risk diagram, or change and risk diagram. Now let's put this reverse fishbone diagram into application. So our first theme for the reverse fishbone diagram is renewable energy. And you can see here the difference is that the head of the fish is on the left side and the arrows are actually pointing outward towards the M's because the change is going outward towards the machine, the measurements. And we're going to analyze how this particular type of project, renewable energy, affects the 6 M's. So we ask ourselves, what's going to change? What impact is going to be delivered? Well, machines, I'm not using the old power station down the street. Now we're going to be using solar cells and wind turbines. That's a change in machinery. Manpower, the type of maintenance and the benchmarking that's going to be done. Now you're not doing benchmarking and maintenance on a power station. Now you're doing this on solar cells and wind turbines. The same thing here with the measurements, the way you measure energy usage, the way you measure energy load, bird migration studies, seasonal effects, and so forth. That has an impact on the energy usage as well. How hard the wind is blowing, if there's a storm, if it's summer, if it's winter, and so forth. Types of materials, whether it's carbon fiber, fiberglass, Kevlar that's used on fan blades for windmills. And then you have the method as well. New procedures that'll need to be put in place before making this big change. Basically, with the reverse fishbone, you're asking yourselves, how is this change? How is this project? How is it going to affect the machines we use? How is it going to affect manpower? How is Mother Nature going to have an impact on us? And how is it going to affect anything in nature itself? How is it going to affect the measurements? How is it going to affect method? And how is it going to affect materials used? All right. So the next change we're going to look at is how 3D scanning impacts a project as opposed to using traditional methods of drafting. And we're going to do a little fun thing here by taking a look at some of my cycling helmets. Both of them I frequently use, but we're going to take a look and try to scan them, get them drafted, and then we're going to study a reverse fishbone as well to try to analyze those qualitative differences between 3D scanning and the traditional methods of drafting. Okay, 3D scanning. What are the effects and what are the risks and the impacts on machine, measurement, method, material, Mother Nature, and manpower. You can see here, 3D scanning should not have an effect on the environment. I could be wrong. Somebody could tell me differently. I'm all ears. When it comes to manpower, I can't speak enough for the opportunity and actual cost and reduction of hours. The number of hours you save scanning a very complex part as opposed to sitting down with the tape measure, with some calipers, measuring it all out, and then drafting it up. Yeah, definitely huge opportunity there. One of the negative impacts could be skill gap with manpower, but you can shore that up with the proper training. When it comes to materials, the negative risks, the negative impacts that you need to watch out for are dark objects, shiny objects, and transparent objects. Scanners have a difficult time scanning those types of materials. Measurements, very accurate, very precise, depending on the type of 3D scanner you require. When it comes to visibility, negative impact as well there. 3D scanners is only going to scan what it sees on the surface. Can you imagine trying to scan all the parts of an engine? You have to disassemble the whole engine. So hopefully somebody already has some designs drafted up, or you got to disassemble everything. So maybe drafting out the parts would be better than actually scanning an engine. Lastly, we'll touch on methods and touch on some of the negative impacts when it comes to 3D scanning. The morals, the legalities, the ethical reasons, the privacy reasons. Yeah, some of those things are going to come into question. You have trademark designs, you have patents that could be infringed upon. You have the risk of trying to scale a design that's not yours, the morals behind that, morals behind reverse engineering someone else's design. Yeah, it's a sticky situation with that. So depending on where your compass is, depending on where your moral and ethical compass is, that may be a negative impact. Probably for me, I could speak freely. For me, it is a negative impact. It's something that I would definitely heed to and watch out for. So here's my helmet. I 3D scanned it. I used my cell phone in conjunction with my scanner. Uploaded the model to my 3D scanning software. Transferred that 3D scanning model over into SolidWorks. And in SolidWorks, you can manipulate the material type, do all kinds of finite element analysis as well, do some wind tunnel testing and other particular softwares as well. The benefit, though, is that it saved me many hours of sitting down and having to draft this out by software, going out and measuring different sections of the helmet. So definitely saved many hours of measuring, many hours of actually putting this within the software as well. Just scanned it. It took about 10 minutes to do and uploaded it. All right, guys, I think we did enough fishing for today. This is Tim Armstrong with EOS Astrius. I'll catch you on the next post. Comment, thumbs up, and subscribe.